Hello mga ka-wisdom! Welcome to Wisdom is Power channel. Kung bago ka pa lang sa channel na ito, huwag kalimutang mag-subscribe, i-like, mag-comment at i-share ang video ito. Click mo na rin ang notification bell to receive more wisdom videos na katulad nito. Salamat! Ito ang pag-uusapan natin ngayon, back EMF and torque. Back EMF, so ang ibig sabihin ng EMF ay electromotive force. It refers to the voltage that is induced in an electric motor or generator's windings when there is a change in the magnetic field. The direction of this induced EMF is opposite to the applied voltage, hence the term back EMF. So makikita natin dito, meron tayong equivalent circuit ng ating DC motor. So yung V natin, ang ating voltage supply, at yung ating RA is the armature resistance, at yung ating I sub A ang ating armature current, at yung E sub B natin ang ating back EMF. So, kung a-applyan natin siya ng KVL or Kirchhoff's voltage law, so yung ating supply voltage ay equal doon sa sum ng lahat ng voltages drop na nasa circuit, within that circuit. So, meron tayong ma-develop na voltage drop dito sa armature. So, ibig sabihin, the back EMF is equals to the supply voltage minus yung voltage drop na madedevelop sa ating armature, which is I sub A multiplied by the armature resistance. Kung kukunin naman natin yung armature current, that will be the supply voltage minus the back EMF all over the armature resistance. The magnitude of this induced EMF o yung ating back EMF is given by the relation E sub B is equal to Z, P, Phi, N all over 60A, where E sub B is the induced EMF of the motor known as back EMF. Ang ating units dyan ay volt, where Z is the total number of conductors in the armature. P is the number of poles, and Phi is the useful flux per pole. Ang unit natin dyan ay Weber or simply WB. So, kung magkakaroon tayo ng conversion, halimbawa meron tayong given na Maxwell, then mako-convert natin yon using the equation 1 Weber is equals to 1 times 10 to the positive 8 Maxwell. N is the armature rotation speed in terms of RPM. And A is the number of parallel paths, where A is equals to 2 kung wave winding ang ating armature, and A is equals to the number of poles for lap winding. So ito ang ating equation to get the magnitude of the back EMF. Let's have practice problem number 1. Calculate the EMF generated by a 6-pole 1,200 RPM lap-wound DC motor. The magnetic flux produced per pole is 7 Weber, and there are 150 conductors. So, isulat muna natin lahat ng given. So, we have pole is equals to 6. The rotation speed is equals to 1,200 RPM. The magnetic flux is equals to 7 Weber, and the number of conductors is equals to 150. And A, or the number of parallel paths, is equals to 6 dahil nga siya ay lap wound or lap winding ang kanyang connection, then the parallel path is equals to the number of pole, which is equals to 6. Then we are asked to solve for the value of the back EMF. So using our equation, we will just plug in all the values given. Then that will be equals to 150 multiplied by 6 multiplied by 7 multiplied by 1,200 all over 60 times 6. That will give us 21,000 volts, or simply the back EMF is equals to 21 kV. Practice problem number 2. There are 380 conductors in the armature of a certain 4-pole wave-wound DC motor. The magnetic flux produced is 100 milliweber, and the back EMF is found to be 225 volts. determine the rotational speed of the motor. So again, let's write all the given. The number of conductors is equals to 380. The number of pole is 4. A is equals to 2 dahil siya ay wave wound. And the flux is equals to 100 milliweber. And the back EMF is equals to 225 volts. So we are asked to solve for the rotational speed of the motor. So using our equation, the back EMF, then since ang hinahanap natin ay yung rotational speed or N, so imamanipulate natin yung equation. So to find the number of speed or the rotational speed, that will be equals to back EMF multiplied by 60 multiplied by the number of parallel paths all over the number of conductors multiplied by the number of pole multiplied by the magnetic flux. So we will just plug in or substitute all the given values to our equation. Then the number of rotational speed is equals to 177 RPM or revolution per minute. So let us try to solve practice problem number 3. A 6-pole wave-connected DC armature has 250 conductors and runs at 1,200 RPM and generates back EMF of 600 volts. What is the value of the useful flux per pole? So again, we have the following given. Pole is equals to 6, A is equals to 2, V is equals to 250, N is equals to 1,200 RPM, back EMF is equals to 600 volts. So we are asked to solve for the useful flux or the Greek letter phi. So based from our equation of the back EMF, we can derive the equation for magnetic flux or our Greek letter phi, which is equals to back EMF multiplied by 60 multiplied by the number of path all over ZPN or the number of pole multiplied by the number of conductors multiplied by the rotational speed. So we will just plug in or substitute all the given values to our equation. Then the number of flux or useful flux per pole is equals to 0.04 Weber or simply 40 milliweber. So let's now discuss the torque developed in DC motor. So in a DC motor, torque is developed due to the interaction of magnetic fields produced by the stator and the rotor. The torque which is produced in the armature is not fully used at the shaft for doing the useful work. Some part of it gets lost due to mechanical losses. So nababawasan yung ating torque dahil meron tayong mga mechanical losses. We have to consider all those mechanical losses. Torque is often measured in units of Newton meters or foot-pounds. So to get the torque developed in a DC motor, the equation for the armature torque is T sub A is equals to 0.159 multiplied by the number of conductors multiplied by the armature current multiplied by the flux per pole multiplied by number of pole all over parallel paths in terms of Newton meter. So an alternative expression can be torque or the armature torque is equals to 9.55 multiplied by the back EMF multiplied by the armature current all over the speed of rotation. Again, so the unit is Newton meter. So let's have practice problem. For number 1, a 50 horsepower, 400 volt, 4-pole, 1000 RPM DC motor has flux per pole equal to 27 milliweber. The armature having 1,600 conductors is wave connected. So calculate the gross torque when the motor takes 70 amperes. So let's have the following given. So from the given problem, the number of poles is equals to 4, A is equals to 2, the number of conductors is 1,600, the rotation speed is equals to 1,000 RPM, the flux per pole is 27 milliweber, and the armature current is equals to 70 ampere. So we are asked to solve for the gross torque. So substituting all the given values to our equation, and the armature torque will be 962 Newton meter. Practice problem number 2. The induced EMF in a DC machine is 200 volts at a speed of 1,200 RPM. Calculate the electromagnetic torque developed at an armature current of 15 ampere. So let's have the following given. The back EMF is equals to 200 volts. I sub A is equals to 15 amperes. And the number of rotation is equals to 1,200 RPM, or the speed of the armature. We are asked to solve for the torque. Then using our equation, the armature torque is equals to 9.55 back A multiplied by back EMF multiplied by the armature current all over the rotational speed. So substitute all the values. That will be 9.55 multiplied by 200 multiplied by 15 all over 1,200, and we will get 24 Newton meter for the torque. Let's have problem number 3. A 6-pole DC motor takes an armature current of 110 amperes at 480 volts. The armature resistance is 0.2 ohms. The armature is lap connected with 864 conductors. The flux per pole is 50 milliweber. Calculate the armature speed, and B, the gross torque developed by the armature. So we have the following given. The number of pole is 6. The armature parallel path is equals to 6 because that is lap wound. So A is equals to P, which is equals to 6. The number of conductors is equals to 864, and the flux per pole is 50 milliweber. The supply voltage is 480 volts. The armature current is 110 amperes, and the armature resistance is equals to 0.2 ohms. So we are asked to solve for A, let the number of speed, or the rotational speed of the armature, and B, the torque developed by the armature. So using again our equation, the number of speed, that is equals to back EMF multiplied by 60 multiplied by A all over Z, P, and Phi. But from the problem, we don't have the value of the back EMF. So we have to solve first the value of back EMF, which is equals to supply voltage minus the voltage drop in the armature, which is I sub A multiplied by the armature resistance. Then that is equals to 480 minus 110 multiplied by 0.2, and we will get 458 volts for the back EMF. Now we have the value of the back EMF, then we can use it to substitute these values in our equation. Then letter A, the armature speed is equals to 636 RPM. And for letter B, to solve for the gross torque, we will use the equation 9.55 multiplied by the back EMF multiplied by the armature current all over the number of speed. So substituting all the values in our given equation, then the armature torque developed is equals to 756.5 Newton meter. So that's all mga ka-wisdom. Again, kung bago ka pa lang sa channel na ito, huwag kalimutang mag-subscribe, i-like, mag-comment at i-share ang video ito. I-click mo na rin ang notification bell to receive more wisdom videos na katulad nito. Thank you at kita-kits the next wisdom video.